Let's discuss question number 2 from test 10. Test 10, this is from strength of materials. Okay, let's see what is asked. The cross section of a bar is subjected to an uniaxial tensile stress. So you have a bar which is subjected to a uniaxial tensile stress of P. So the stress is P, directly a stress is given. So, and what is asked is the tangential stress on an inclined plane 20 degrees to the cross section of the bar. Okay, so 20 degrees from the cross section means I assume that from the vertical it is 20 degrees. So this is how it is made from the vertical 20 degrees. So obviously the normal of it with the horizontal will make 20. Okay, so now if you recall the formulas for inclined stress, if you have an element which is subjected to, let's say, sigma 1 and sigma 2, I'm just writing out the normal, and if you have a plane which makes an angle theta with the horizontal, so the normal stress on this, so on this plane will have both normal stress and the shear stress. So the normal stress formula will be on the inclined plane will be sigma 1 plus sigma 2 by 2 cos 2 theta, plus if you have a shear stress, so let's say the shear stress is not there, so this is, and the shear stress on the inclined plane is sigma 1 plus sigma 2 by 2 sine 2 theta, with the minus here. That minus depends on whether you are taking this to be positive or that to be, but the formulas are this: when you don't have shear stress, you have only the biaxial stresses. Okay, so now what is asked is, in this problem you have only the uniaxial tension, so it falls in this biaxial, general case of biaxial tension. The tangential stress on an inclined plane, so the tangential stress is nothing but the shear stress that on an inclined plane. So sigma 1 is P, sigma 2 we don't have, 0, and theta is 20 degrees. So if I substitute it here, I'll get tau as minus P plus 0 by 2 sine 2 theta, so 2 into 20, that is sine 40. So P by 2 minus sine 40. Now minus sign depends on whether while deriving you have taken this as positive. Some would take this shear stress to be positive. So it's all, so now if you look at the magnitude only, it's P by 2 sine 40 is the answer. So the answer for this is C. If you are stuck up with the formula, you don't know how to apply the formula, I would suggest just take only the left side, the bar, okay, and then now do the force balance, find out the tangential stress, and then find out the normal force and the tangential force, and then divide by this area. Tangential by this area will give you tangential stress. The formulas, if you remember, it's better. Otherwise you have to do a static equilibrium, force balance, find out the normal force, take the left side of the section on the inclined plane, left side or right hand side, and just balance it, find out the normal force and the tangential force, divide the tangential force with the inclined area, you will get the tangential stress. So the answer for this is C. Thank you.